In this video, we're going to figure out why we're getting these issues with our audio waveform right here, where it's highlighting words that are clearly not silences. And we're going to learn a lot about Whisper and the transcriber model, because ultimately these issues, as you can see down here, it's highlighting this whole segment in the bottom left as silent. And that's a result of the Whisper transcriber model. Stay tuned to see what we can learn about this transcriber model. Okay, I'll just start up the application with npm start. I'm only starting up the front end because we're only working with the front end. Let me navigate into the edit page where we're going to be making changes. So if I click detect silences, we can see that we have these regions, and at least some of these are not correct. Let me just zoom out so that you can see, because I think I'm in the way. But this region right here is obviously not silent, and neither is this region right here. If I click play, you can see that it does say, it does have speech there. So I need to correct those two. So I'll look into the transcription. So let me pull up the transcription that we have on this. And if I go back, I want to find where this word is before I purchased it, to see how this is the phrase right here that is being cut off. Just scrolling down till I find it, purchase it, to see how right here. So I don't notice anything unusual on why, I should be looking at this one right here, why it would be cut out, aside from it being too small. That might be the problem. The length of the word is only 60 milliseconds according to this, or 0.06 seconds. And so when it's calculating silent regions, the interval that it's checking might be greater than 0.06 seconds. So let me go back in here. I'm trying to remember, what is it that's calculating the gap? I think that's in my video editor context. Let me just see if I can find gap. And I'm actually going to start using cursor a lot more. And just to ask it questions, I'm going to use 4.0 mini so that I don't use any of my premium uses. And I'll provide it with video editor context. I just want to know, does this file contain a function that calculates the silence in the audio waveform? And I just remembered it's the function called detect silences. So wherever that is, I can just search it. Okay, so I did find it. It is in this file. This is it right here. So let me look through the transcription. Actually, now that it found it, I can ask it, what part of this code calculates the silence gap between words? Submit that. And here it is, segment words. So let me search that. Segment, oops, words. It's just segment words. Okay, so I found it. It's right here. Okay, now I actually found it. It's this one right here. Iterate through words within the current segment. And if I go back into the transcription, we are within one segment, so it's not an issue with it jumping to the next segment. So here's the part where it calculates the gap, and as long as the gap is greater than the threshold, then it's silent. So I want to see specifically when the next word is how, right here. So let me just add some console logs. I'll accept what it's suggesting, gap between word and. Okay, so the gap between the current word and the next word is roughly this amount of time, and I only want it to log it when I'm on this word right here. So maybe I could just set the start time to be 16.00099. Actually, for now, I'll just log it every time, for every word I should say. So let me add, is it word.word? And I have to wrap this, not work, it's word. So is that gonna work? Is that how it's written? What's the format of our words object? Okay, so the segments themselves are coming from the transcription, which is loaded here in this edit page. When we set the transcription, we're just setting it to the data, and the data we're just getting from the transcription itself. So I just have to look at the format here. It really does help to have typing in your applications. That way you don't run into this problem where you're trying to figure out what's the structure of your variables. So in the future, we'll work on adding that. But for now, let's see, we have the segments. Each individual segment has ID, text, start, end, and words. And then each word has word. So it is word, word.word. Okay, so I'll just want to log that. And then let me add the next one. So next word dot word. That'll log for everything. And this is logging. This is happening when I run the detect silences function, which is when I click on that button. So let me go back to my app. Let me open up the console and click detect silences. So let me just look for these logs. Okay, so here it is. Okay, so I found the log. It's this one right here. I should have added quotes for the words from the transcription to make it easier to read these logs, but this is the one. So the gap is roughly 1.34 seconds. Let me go back to this part and listen. Okay, so it's saying that the gap right here, if you can see my mouse, the gap between C, where it ends right here at the beginning of the border, and how is 1.34 seconds. But the next gap between how and what comes after, which is much, because it's the phrase to see how much, it says it's only 0.02 seconds. Obviously, this would fall within, it would meet the criteria of like exceeding the threshold, but are these timestamps correct? So 16.26, and that's for the word C. Let me go into the transcription, find that word here. Okay, so I found it right here, and the actual timestamp is, yeah, so it is 16.26, and the start of how is 17.6. So it is correct in calculating. It did calculate it correctly. It's the transcription that's wrong. Because if I were to go into this transcription and edit it, let me just make a small change right here. Okay, so I just adjusted the start and end time of this word how so that it could be a little bit more accurate. And then if I click detect silences, I still didn't get it correctly, but you can see that it's in the error is in the transcription. So the Whisper model didn't transcribe this word very accurately. And I'm guessing that it's because it was just so narrow in the speech. So whatever threshold Whisper has for detecting the words as they're spoken, it was probably too small for it to detect it accurately. But I can just adjust this to be like 16.8 and then this 16.9, whatever. Refresh, hit detect silences. And this time it didn't select it, and it's because the gap was probably less than 0.8 seconds. Anyways, that shows us that the transcription model sometimes does make mistakes, and that's one reason why we need to be able to undo some of these cuts that it does before I send them over to the backend to get them edited. Because we wouldn't want to cut out anything that's important, right? If I had just accepted whatever silences it detected as regions to cut out, and then I had a feature where I can export this video, then it would have cut this part out and I would have missed a word from my speech. And you can't afford that in a production level application, right? You don't want to have those kinds of mistakes, because if you're cutting out people in their videos, or you're cutting out important parts in speech, then your users may not like your application because it just has too many things wrong with it. So I'll add that to the to-do list so that we can look into how can I improve the transcription returned by the Whisper model. Sometimes it misses words if the word was said quickly with lots of silence before and after. I just made a note of that so we can work on it later. Okay, the next issue I want to look at is the beginning of the audio waveform here. So I actually have these logs, so I should be able to see what the gap is. Let me improve the log a little bit. Okay, so just coming in here where I had written the log before, and I just want to wrap it in quotes. That way it's easy to see what the word is in the logs. And then the phrase we're looking for is in the beginning. So the transcription says, all right, this is a 2016 Jeep Wrangler Sahara 75th anniversary. It's got all the upgrades you could want. Tires have minimal wear, and so on. I think that should be enough. So let me load the application. Click detect silences. Let's go into the logs here. Let's go to the beginning, and we have, all right, All right, so all of these silent regions that it's detecting are, most of them are less than 0.8, I mean. Yeah, even this one's less than 0.8. This one's negative. That's probably what's causing the problem. Here it is. So it says the gap between A and 2016. Remember the phrase is, all right, this is a 2016 Jeep Wrangler. Anyway, so this is probably what's causing the issue. It gave the word 2016 an ending timestamp of 0. So let's go into the transcription. Let's open up that segment and we're looking for 2016. All right, it's right here. And you can see that this timestamp is also wrong. Okay, so I just corrected it here. I just put some random numbers that fit within this sequence. And even the score, it had given it a 0. So that was odd behavior. Let me just refresh and click detect silences. Okay, so it still has an issue. But at least we know that was one of the problems. So let me make a note of that as well when we're looking into the Whisper model. Or sometimes the words don't have a timestamp in the transcription. Okay, let me go back into the app. Let me refresh the app, clear out any logs. I just want to see the logs of the gaps. So instead of logging every single line, I think I'm just going to see if I can just log the negative ones. Like this one right here, this is another problem. Yeah, so I'm just gonna log when it's negative. I'll go back into here, into where I have my log, and I'll write an if statement if gap is less than 0, or if it's equal to 0. I forgot I'm not working with Python, so let me just write the proper syntax. Okay, so I just fixed the syntax for this log. Now I can go into my application, reload, let me clear out the logs, hit detect silences, and then I can see here it is. So it looks like there's probably just one issue. Maybe another one will come up once we fix this one, but the word is like and 8,000. So I'll just make that correction in the transcription. So I found it, here it is. Again, it's just giving it a timestamp of 0 and the score as well. So I'll just make the correction. Okay, so just gave it some reasonable values considering where it is in the sequence. And then I'll refresh the app, click detect silences, and that problem is gone. So this was all just because the transcriber model gave us bad transcription. And if I hadn't made the manual corrections to the transcription, this whole region, as well as this word right here, would have been cut out. So that's definitely a high priority item that we'll need to look at probably in one of the next few videos. You know what, on second thought, let's look into it now because this is a pretty big problem that we don't want to have to face. So I'm going to start my search in Perplexity, and this is where I'll ask it some questions so that it can look into Whisper and see how we can improve the accuracy. Okay, so I'll prompt it with, I'm using the WhisperX Python library on GitHub to transcribe audio files. This library is using OpenAI's Whisper model, so I am basically using the Whisper GitHub repo by OpenAI to transcribe my audio files. I am facing a problem with these libraries. Sometimes the word level timestamps that Whisper returns are not accurate. Some of the words will have a value of 0 for their start, end, and score. Sometimes the timestamp of the word is wrong if the word was said briefly with lots of silence before and after. What can I do to fix this problem? And let me enable Pro Search. It's going to do some thorough research, some advanced analysis, and that takes several minutes. Sometimes it takes like 30 minutes, I think. So I'll let that run in the background, and in the meantime, I want to know if the issue is coming from WhisperX or Whisper. Because if it's WhisperX, then it's an issue with how they are calculating the end of words so that they can get the precise word level timestamps. Whereas Whisper just gives you, if it detects a word, for example, this word right here is the word how. So if it detects this in the transcription, what it'll give you in the word level timestamp for this specific word will include all of the silence that follows that word. So it'll stop around there. And that's basically the timestamp for that word. So what I'll need to do is go to my homepage, and then I'll upload a file, have it get transcribed by the backend, and I'll configure the backend to use Whisper instead of WhisperX. And then once I get the transcription from Whisper, I'll know if the issue is coming from WhisperX or Whisper. And I'll run the audio through each of those twice just to make sure that the results are pretty much the same, because these machine learning models are stochastic. They're not deterministic, meaning that they're not always going to give you the same result. And so it could be that if I were to run that audio through the transcriber multiple times, either most of those times it can get accurate transcriptions, or maybe it'll have different issues each time I run it. But that's what we'll find out. So Perplexity finished with its response before I could even start testing with the different libraries to see if I could get them to produce more accurate timestamps. And in its response, it says that these inaccuracies in the timestamps are fundamental limitations of Whisper and how it generates timestamps, because basically Whisper was trained to generate accurate transcriptions, so to detect or to figure out what the word is accurately, but it wasn't trained to know exactly when that word was set. Here it's just saying that Whisper uses what's called transformer-based models trained with a cross-entropy criterion. Basically, when Whisper was trained, it was just told when the word was correct versus when it wasn't correct, and it looked at the entire sample all at once instead of one by one. So instead of listening to the audio in sequence, it was processing it in parallel, I guess. So Whisper uses non-uniform audio processing, meaning that it splits up the audio into chunks, and sometimes that chunk may cut off a word, so it doesn't really correspond to like the word boundary. And Whisper was trained so that it could predict words at the segment level, so the accuracy is just about 1 second, which is not great for our use case. I mean, it is a really amazing model, but it's not good for our use case. And so the solutions that it has to improve this is to use forced alignment with better models, but WhisperX already implements forced alignment with wave-to-vector models. And it says, here's some recommendations for how we can further improve this. Basically, we can use a larger Whisper model with a specific alignment model to get better results. If I look at the source here, I think it's just the WhisperX. Yeah, it's just the WhisperX repo. And in this example, it's just giving us a specific alignment model that it's using. It looks like it's a wave-to-vector ASR large LV60K 960H. I wanted to know what this model was, so I looked it up. And apparently it was developed by Facebook, Meta, and it's a speech-to-text model. So some details that we can get from this name is that it's the second version of this model, and it's an automatic speech recognition model. This is the large version, and it was trained on 60,000 hours of speech from many languages, and it was trained a little more on English speech. So yeah, we can look into that if we don't find something better. That's a good suggestion that it has. Another solution to solve our issue is to add a voice activity detection preprocessing step. And here's the VAD model that it's using. It's one called Celero. And voice activity detection does a lot of things that are inherent in these speech-to-text models. So example, it can detect actual speech segments more accurately. It can reduce hallucinations in silent sections. That's actually a really big issue with Whisper. If you were to upload an audio that has a really long silence period, then it'll start to hallucinate. And sometimes it'll respond with, "Thanks for watching, subscribe to my channel." So you can tell that it was trained on a lot of YouTube videos. And lastly, voice activity detection provides cleaner audio segments for the model to process. And then the third solution to get more accurate timestamps are 3 different libraries that it mentioned. I think we had looked into Whisper Timestamped. It wasn't as popular as WhisperX. That was a few videos ago. Another solution is we can adjust the parameters for the VAD so that we can get better results for our condition. So here it's just setting the VAD threshold and then the minimum speech duration in milliseconds. And what these parameters mean are explained down here. The threshold is just a speech probability threshold, so how likely is it that there is speech in the current chunk. And then the minimum speech duration is how short those speech chunks can be that the model processes. And the minimum silence duration is how short the silence can be so that it marks the end of a word, I'm guessing. And then the fifth solution it suggests is to improve the audio quality. So you want to normalize the volume level so that the lows are higher and the highs are lower, so that as you're listening to an audio, it's more normalized and even, so you don't have like these really quiet audio pieces or these really loud ones. You can remove background noise, ensure the audio is consistent. Obviously, when you're hosting a public application that lots of users are going to be using, they're going to upload all kinds of audio, and it's your app that's going to have to do a lot of this processing. But even still, the audio quality may not be so good, and your users, they're not going to be super understanding. They're going to want to expect really good results even if they upload a video where they're speaking and they have SpongeBob SquarePants blasting in the background. And then it has some post-processing solutions that it recommends in order to get more accurate responses. And it comes up with a workflow. It's just using the solutions that we already looked at. This is a workflow for how you can process the audio to get these accurate word level timestamps. And for the solution, in conclusion, these limitations are inherent to Whisper's design and they're not bugs. So if we're dealing with mission critical applications that require perfect word level alignment, we either need to combine multiple approaches like this workflow up here, or we can use specialized transcription services that prioritize timestamp accuracy. Whatever choice we go with, we're going to do that in some future video. Right now, I would like to continue working on the features for the application, but it is good to know, it is good to have done this research so that we know what to expect from our application and start to think about what methods we might want to implement if we want to implement some kind of workflow like this where we have some post-processing, pre-processing of the audio, or if maybe we want to start looking into using a library that already fixes these issues. I'm thinking DeepGram is probably going to be the best, but I haven't done a ton of research to see if they're still the best speech-to-text model out there. I know that Descript uses Google's speech-to-text model, and in the past, I didn't get really good results. In fact, I got terrible results with it, but I also didn't really configure it or do any research on how I could configure it. So it's possible that it can do a really great job, especially because Google owns YouTube and they have all those audio samples that they can work with. I imagine that they probably can produce a model that does better than Whisper. So we might look into using Google as well if we can configure it and it can do a lot of these things for us. So I wanted to learn a little bit more about this issue and see if I could get more answers from other sources. So I asked ChatGPT and I used deep research. They just made it available to free users. I'm not paying for ChatGPT because there's just so many tools right now that I'm using, but I do like using ChatGPT. I have nothing against it. Right now I'm just using Perplexity for a lot of my research, and then most of my work is done in Cursor, so I don't have a need for more than that. And in the past I had a few months subscription to ChatGPT, but if I were to go with an LLM model, then I'd probably use Claude for now because I've been liking the results I'm getting whenever I have questions, especially because my questions have to do with code and Claude is better at generating code and understanding it, whereas Whisper is more for like creative writing, although it does really good job at code. Anyway, so I asked ChatGPT, I'm wondering if it's possible to configure the parameters of WhisperX in order to get more accurate timestamps. I read somewhere else that Whisper was not designed to give accurate word level timestamps. It was designed to give accurate transcriptions. So there are probably other libraries or models that are better suited for this. Feel free to suggest other libraries or models if there are others that are known for being highly accurate at word level timestamps. Please do look into post-processing techniques that correct or interpolate bad timestamps, but if you find another library or model that can already do this accurately without having to use these post-processing techniques myself, then just provide an explanation of these post-processing techniques. You don't need to be super thorough or make this the main focus of your research. And it thought for about 5 minutes. It used 36 resources and 72 searches. And here's what it said. WhisperX uses forced alignment stage on top of Whisper transcripts to produce word level timestamps. But you can tune WhisperX and its alignment model to get better timing. In fact, it's even mentioned in the WhisperX README that if you use larger models, you get more precise timestamps. But that does cost more GPU memory, so just use the biggest Whisper model that you can afford and a high capacity wave-to-vector2 aligner. And here's something that's important. It says that WhisperX suppresses numbers because the wave-to-vector2 aligner can't align tokens with out-of-vocabulary characters such as digits and currency symbols. And that's exactly what we saw in our transcription when we were transcribing numbers. They didn't get a timestamp like it says here. Anyways, you can read the rest of this here if you'd like. I'll just scroll through this so that you can refer to it if you want to do some more research in this area. But here's the response. It's also mentioning these brief post-processing tips that it has. And yeah, it looks like that's the end of the response. So I actually got it to work. Let me just refresh the app and I'll show you. If I scroll down to the bottom here and then I click on detect silences, you can see that it's no longer cutting out the silence in the intro. Maybe you can't see because I'm in the way, but if I zoom in, maybe, okay, I just have to zoom out, but you can see the audio waveform is here, and now the transcription has been corrected. I had made some manual edits to the transcription in order to get it to work, but I overwrote those changes with the transcription that I generated after configuring WhisperX with some parameters in order to get it to transcribe more accurately. And if we look at the audio waveform, we can see that any silent regions are actual silent regions. There's no words that are being spoken for all of these automatically selected regions. Although I do notice that there's this region right here. There's this word right in the middle, it looks like. There's some sound there. If I zoom in, I wonder if that's actually a word. So this right here, this noise isn't actually a word. The transcription didn't pick up this silent segment here, which is obviously large enough because there's some smaller ones right here. Like this one even satisfies this criteria for 0.7 seconds. So this one would definitely should be picked up, but it didn't. But I'd rather have false negatives than having false positives. So meaning I'd rather have regions that were not picked up than some regions like over here where it was getting picked up as a silent region when it really wasn't. So for the command, it's this one right here. Let me just adjust this here and I'll zoom in so you can see it better. So here's the command. I just made sure I'm in the server directory because that's what has my virtual environment. If I look at my project structure, I have this server here, and then in here I have the virtual environment that we've been using for our backend. And then the command, I just ran WhisperX because the WhisperX is installed in this virtual environment, and I ran it on this file, which is the same one that's in my public directory here. In fact, let me just change the path to that file because I'll run it again. So I just updated the path and I'll just make it a relative path. And then for the model, I chose large version 2, and then I chose a large alignment model, and I think this is what made the biggest difference. Batch size is 4, compute type is int8 because I don't have a GPU, and then I have it set to highlight words as true, and the VAD onset is 0.45. And with these parameters, I'll show you how it works. If I go into my changes, you can see that this is, let me zoom out. This is the transcription that I had before, the first one that we've been working with since the beginning of this video series. And I replaced it with the one that I generated with this command here. And so it overrode everything basically. But just to show you that it works, I'm going to stash this. So I'll run git stash. And now we're back to using the transcription that I actually had manually edited, which won't have any errors because I had made those corrections, but let me load it anyways. So you can see the audio waveform. I click detect silences. Right, this is the one that we had corrected manually, but we don't want to have to do that. And so that's why I looked into how I can configure WhisperX with the proper parameters so that I could get an accurate transcription with words. But let me just introduce some errors into this transcription. I'll include them back where I had them in the beginning. I think it was with the words, is not the words, the numbers that I had an issue with. So let me just put 0 for all of these. And let me just open up the actual transcription file. Okay, so here's the word 8000. And as we saw, WhisperX specifically has issues with getting the timestamp right whenever it's special characters or numbers. So I'll introduce that issue again, and then I'll click detect silences, and we can see this was the issue we were facing before, right? So I just wanted to introduce that error so we can see how we're overriding it. Okay, so I just run this command first. I move into the server directory, and then I activate my virtual environment. Once it's active, then I can run the command down here. I fix the path to the file just because we're in the server directory, so just make sure you have that correctly. And then I ran it, and you can see that it detected the language. It starts transcribing. So here's the first chunk. It's 9.5 seconds. And then the next part, and so on. And then after, it starts to perform the alignment after it gets the transcription. And then it looks like it generated these files over here on the left. So it has all of these files, including this one, which is the transcription. So I'll just move that one into here. I'll delete the old transcription that I have. But before I do that, I want to make sure I stage this error that I had introduced so I don't overwrite that. So going back over here, I want to delete this file because I'm going to overwrite it basically. And I'll just rename this one to transcription. So effectively, all I'm doing is replacing the file contents with the most recent transcription. The format isn't good, so let me just fix the format real fast. Run format document, save it, and if I look at the working tree, I can see it replaced the old transcription. So it mostly replaced just the timestamps and scores, sometimes the phrases, but for the most part, it's just the timestamps. And if I just refresh the app, and then I go down to detect silences, we can see that this new transcription, which was generated with our command, is generating the transcription accurately that matches the audio waveform. Amazing, so we got it to work. Okay, one last thing I want to mention before I end this video. It's not relevant to what we've been working on, but I just wanted to share that I installed Codex, the Codex command line interface by OpenAI, and I had it run on my video app editor, and I gave it the prompt, refactor my code so that it uses coding best practices. You're free to organize the structure of my files. And then it ran all these commands. It looked at the entire code base. You can see that it was thinking. And then here's some changes that it made. And then it asks me, does the outline look good? So this is actually before it makes the changes. And it just says that it's going to make these changes as long as they look good. So I say, yes, they look good. And so it continues looking through the files. It's just reading my code here. I'm going to scroll down to the next part where it prompts me again. So after it's made the changes to the front end, it says it pulled out the plumbing from the React context, and then it organized the structure, and then it asks me if I wanted to proceed to refactor the backend. So I say yes, please proceed. Continues to look through the code, and then it gives me a summary of all of the changes that I made to the backend. So this is the part where I reviewed the changes that it made, and I'll show you what those changes are. But first, let me stash this, the changes that we have. Take a look at our commits, and then I'll just reset the last commit. And we can see that it changed all these files, and it actually changed a lot more than this. It separated out some utility functions into their own separate files so that it's structured better. But actually, a lot of the code that it generated wasn't any good. I didn't like the refactoring changes that it made, and even the ones that it did make, some of them weren't so good. There were a few that I kept, like this one here. I moved this function out of the video editor context, and it moved it into a utility function. You can see up here on the right hand side, it's now importing this function called detect silence core, and this is what's ultimately doing the same thing as what add unique trim history items was doing before. And the last thing I wanted to see is how much it cost me. So I went to OpenAI and I can see that for the day that I ran it, refactoring that code cost me a whole dollar, almost a whole dollar. And that does make sense because I did provide it with a lot of context. You can see that it used over 1 million tokens in context because I basically told it to look at the entire code base. But since the code that it generated wasn't that great, spending a whole dollar for that request I think was a little bit expensive. Anyways, I just wanted to share that so that you know why there are some changes in the project that I didn't go over. With that, I'll end this video. We got the transcription to work as we wanted it to. We found out that the issue that we were having with the silences was because the transcription wasn't very accurate, and then we found a command that can get us this accurate transcription based on the parameters that we configure here WhisperX with. Well, thanks for watching. Hope you learned a lot in this video, and I'll see you in the next one.